Alright, here we go. We're getting ready for exponential graphing properties and transformations of the exponential function. So let's go back and look at something we already know. Here we have a quadratic equation in transformational form. I want to know what are the transformations. Well, if I look at it right off at the very end, I know that's my k-shift, and that takes it down 1. Right in here, this is x minus k. So it always goes the opposite direction when I set that equal to 0. So x plus 2 equals to 0. So I would subtract the 2, and so this is going left 2, because it always goes the opposite direction. Out in front, the absolute value of negative 3 is 3, so that is greater than 1. So this is a vertical stretch. And last but not least, this negative out in front here, what it does is it reflects the x-axis. So if I had a little baby parabola here, and the parent parabola would have started here at the origin and gone up like this, this one has, the vertex has been moved to the right 2, to the left 2. So it would move left 2 and down 1, so the vertex would be here. And instead of opening up, it's not going to open down, and it's going to be a little skinnier because of the stretch. So this would be the original parent function, and after all the transformations, I would have something that looked like this red one. Okay. Now here I have a, looks like a polynomial raised to the 4th degree polynomial, because I have 4 x-intercepts. It asks what is the domain and range of it. My domain is going from left to right. There is nothing restricting this, because as I go up, I also go left. As I go up here, I also go to right. So my domain would be negative infinity to positive infinity. My range is a little more complicated. As I look at it, my range is starting at the very bottom. First thing I see is this point, which also has the same y value as this point. So I'm going to write that down. That is a minimum. So that is negative 2. And it goes all the way up to infinity. You can never touch the infinity, so that's a soft parenthesis. This negative 2, did I touch it? Yes, I did. So I have to have a hard squared off bracket showing that I actually touched that negative 2. There is my domain and range. Transformations. If I have a parent graph, y equals b to the x for my exponential, my transformational equation looks like this. A times b raised to the x minus h plus k, where k, that's kind of like my kite, and that takes things up or down. It's also going to move my asymptote. And it's going to move that. This is my h. It moves things horizontally left to right in the opposite direction. In the opposite direction, because I have to set it equal to 0. We said that before. Anything that's bound up with the x, we set equal to 0 and solve. It shows us which way we are actually going. My a tells me if it's a stretch or a shrink. So if the absolute value, should have been absolute value signs here, if the absolute value of my a is greater than 1, then it is a vertical stretch. If 0 is less than the absolute value of a, which is less than 1. So in other words, I have a decimal like 0.5 or a fraction like 1/4. I have a proper fraction or a regular decimal. Then I have a vertical shrink for my A term. It determines stretch or shrink. I can have a reflection about the x-axis if my A is negative. So if A is negative, then the graph has a reflection over the x-axis. What this means is my regular exponential growth function would look something like this. If I have a negative reflection, it's going to reflect over the x-axis, and it's going to go down something like that. So that's what reflection over the x-axis looks like for a growth function. If A is positive, then there is no reflection about the x-axis. So the one to remember here, if A is negative, you reflect over the x-axis. Talked about this briefly already. Vertical shift. If I have something adding to the very end of the function, not adding to x, but adding to the very end of the function, if it's positive, it's going to go up. If it's negative, it's going to go down. So if k is positive, it goes up. If k is negative, it goes down. That one's easy to see. It goes the direction it looks like. The horizontal shift's a little more tricky. Take it, set it equal to 0. X minus h equals 0. And solve. So what I'll find here is if I have a positive h value,